All right, so today we're going to get into predicting the products of a chemical reaction. So in this case, if we know the reactants, we should be able to figure out at least an option for what the products are going to be. Now depending on the reactants, there might be a couple different products that could be made, but for the most part, there's usually only one way that it's going to react. So what you have to do to begin with is you're going to be given reactants, and what you need to figure out is what type of reaction is going to happen, because the type of reaction is then going to tell you what your products need to look like. So you need to see, is it synthesis, is it decomposition, single replacement, double replacement, or combustion. So this first one here, we have sodium Na plus chlorine. Okay, so we have two elements coming together or reacting, and the only thing that they can do is come together to form a compound. So this is going to be a synthesis reaction because it's two elements. So because nothing can switch, we can't break anything apart. So therefore this is going to be synthesis. Well, if it's synthesis, we're going to make them come together. We know that sodium is in group 1, so it says a +1 charge. Chlorine is in group 17, so it has a -1 charge. So it's going to make NaCl. Okay. +1 and -1, the charges cancel out. Then we would have to balance it. Since I have two chlorines here, I would need two over here, so I'll put a 2 in front of the sodium chloride. That gives me two sodiums, which makes me put a 2 there. And then it's balanced. Okay, so that's easy, they just come together. Now here's the next one. We have just one reactant. If we have just one reactant, the only thing that can do is break apart into multiple elements, or maybe a compound in an element. So that's going to be decomposition reaction. So we have N and H. We're going to break it apart into N2 plus H2. It's going to break down into N2 plus H2. And why do I put a 2 there? That's because those are diatomics. Those are part of Brinkelhoff. Remember, if you have an element from one of those 7 elements, when they're by themselves, they have 2 atoms bonded to each other. They're diatomic. So now I have to balance this. I know that I have 3 hydrogens and 2 hydrogens, so I need to get them equal to 6. So I will put a 2 here to make that 6, put a 3 there to make that 6, and then that 2 there balances the nitrogen, so we're good. Okay. Now for this next one, we have lithium plus magnesium fluoride. So we have an element that is reacting with a compound. And what happens here is the element is going to replace one of the elements in the compound. So if this is a metal, which lithium is a metal, it's going to replace the other metal. So we're going to have lithium fluoride. That 2 is there because magnesium's charge is +2, so we needed 2 fluorines. Lithium's charge is only +1, so we only need 1 fluorine. And then, so lithium is going to take the place of magnesium, and then magnesium is going to be by itself. So if it's single replacement, this is single replacement. Sorry, forgot to put that. The metal will replace the metal. If this was a non-metal, it would have replaced the non-metal. So, and then the one that you kick out kind of gets by itself over here. Then we'll have to balance this. So I need 2 Fs. And then that gives me 2 Li's, so I'll put that at 2 there. Okay. All right, this next one, we have 2 compounds reacting together. Anytime or almost anytime you have 2 compounds together, that's going to be double replacement. In a double replacement reaction, the outsides go together on the other side and the insides go together on the other side. So in this case, I have rubidium and nitrate. Since rubidium is +1, nitrate is -1, it's just going to be RbNO3. And then we have iron 2. So iron is +2, nitrogen is -3, so it's going to look like this. Okay. And then I need to balance this. So I will put a what do I need, a 2 here to give me 2 nitrogens, and then a 3 here to give me 3 irons. That gives me 6 rubidiums and 6 nitrogens, so I need a 6 there for my RbNO3. Okay. And then this final one, we have a hydrocarbon plus oxygen. That should be a dead giveaway that we have a combustion reaction. And in a combustion reaction, your products will always be carbon dioxide and water. And then we need to balance it. I need a 2 here for the carbon. I need a 3 here to balance the hydrogen. That gives me 4, 7 oxygens. That's not going to work because I only have 2 over there, so I need to double this. So put a 6 and a 4, then put a 2 there. That gives me 8, 14 oxygen, so I need a 7 there. Okay. So that is how you predict the products of the different types of reactions. Again, the first thing you have to figure out is from the reactants what type of reaction it is, and then go from there. All right, I hope this helps. Let me know if you have any questions.